we will give a demo about co-simulation environment. Why are we talking about co-simulation? Co-simulation allow you to model your system early, and it will save you time and resources. It allows you to develop both hardware and software in parallel. So the software team can work on the actual hardware just using a simulation environment before the hardware is actually available. This slide shows the two sides of the co-simulator. On the right hand side, which is the System C simulator, it composed of the peripherals that you see marked as Louis LMAC Core 2. And it also have DMA engines that DMA the Ethernet MAC packet in and out of the system memory. And it has a virtual file which emulating a file for the Ethernet, and that actually get virtually connected back into the real hardware port so that you can go in and out all the way out to the internet side. On the left hand side is the QMU, which has the Zinc processor side of it, which include the ARM CPUs, and on top of that we run the Linux kernel and a demo app. The demo application is really retrieving packets and sending packet, and the Louis Mac Core has ability to do 10 gig, 5 gig, 2.5 gig, and 1 gig. And today Sonny is going to demo you that on the cosim system. Okay, so for this part we will show the demo of the co-simulator. What do you got on the right hand side and what you got on the left hand side, Sonny?
So on the right hand side we have a programmable logic terminal, and on the left hand side we have our QEMU terminals. So we'll run the QEMU script on the left hand side of terminal, and we'll run our programmable logic script on right hand side.
Okay. Okay, so on the left hand side you started the System C, and then on the right hand side you started the QMU. Or is it the right hand side is System C, the left hand side is the QMU?
Yeah, so on the left hand side I started QMU and executed the script. The script indicated QMU of which machine to emulate, and also it boot up the system.
Okay. Okay, so the system's going to take some time to boot up, so I'm going to turn off the video for a minute.
The left hand side of the window shows QEMU terminal, which is booted up, and now we log in as a root. Now we will bring up the Ethernet port.
This is the emulated port using the LMAC Core 2 from Louis.
And then using Linux if config command we can look at some statistics. So here we can see that Ethernet 1 port is up, and the MTU is 1500, and also we can see some addresses. So now we'll try to download a file from the internet, a text file from the internet. The 100% shows that we have successfully downloaded the file, and then we will open the downloaded file. Here you can see like two happy faces smiling, and the connection is successful between QEMU simulation and System C simulation.
So two guys can talk, two systems can talk, and they are laughing.
Yes, absolutely. And now I'll be showing you the pcap file which we can see on the Wireshark application. So number 18 shows that we talked with www.textfiles.com. It is the site um, that we accessed from Ethernet port on QEMU simulator.
So this is the address 10.0.2.15, so it's connected to the internet, but this is on the ETH1, which is the emulated Ethernet port.
Yes, absolutely. And then number 25 shows the file that we downloaded from the internet, that is sk.txt. And then I will be showing you some waveforms that we captured using model sim. So here is the transmission path waveform from software to virtual file. We can see that the data from TLM to Axis bridge is transmitted and goes all the way to virtual file. We can also see the zoom in view of the captured waveform. This waveform shows that we have data available on TLM to AXI stream protocol, and that data is transferred to AXI port of the Lewis Mac core. After receiving the data on Lewis Mac core processes the data and attaches the preamble sequence and startup frame. This can be seen by cursor 3. And then Lewis Mac core transmit the data to virtual 5. Cursor 4 shows that the data is sent to virtual 5, and CRC and end of frame have been added.
So this is showing the detail of a packet being transmitted all the way from software out to the file.
Yes, and we can also see the receive path all the way from file to software. This waveform shows receive path from virtual file to software. It can be seen that we have data available on virtual file which is transmitted to Lewis Mac, and on receiving the data, Lewis Mac transmits that data to software using DMA. Next, I'll show you the zoom in view of the received packet. So here cursor 1 shows that there's a data on virtual file which is sent to Lewis Mac receiving port, and Lewis Mac manipulates the data and removes the preamble sequence and startup frame, which is shown by cursor 3. Cursor 4 shows that data is transmitted successfully to the software using AXI to TLM bridge. And thus we can verify the functionality of Lewis Mac core hardware and also the software.
So this demo is showing the software on the QEMU side and the hardware is on the System C side, and what you have just shown is the Wireshark capture on the emulated port so that we can see the packet actually go back and forth, and then you show the waveforms here so that you prove that the hardware actually wiggling up and down and do the transmit and receive with the packets.
Yes, absolutely.
So everything seems to be working fine.
Yep.
Thank you, Sunny.
Thank you very much.